Hello all, today I am going to discuss about the basics of multiplexer. First, we need to know what is multiplexer. Multiplexer is a digital circuit and it is example for combinational circuits. So we all know what is combinational circuit. Right? Combinational circuit is also a digital logic circuit whose output is solely on the present combination of inputs and it does not need any memory or feedback to hold the past outputs. Hence, the multiplexer is one of the best example for the combinational circuits. Okay, multiplexer is generally known for digital switch because it allows digital information from the several sources, but that all should be routed on a single output line. Even though it has n data inputs, only one output is selected and the selected output is delivered at the output side. Hence, it is simply called as many into one. So, how the data is selected is by means of the selection lines. Okay, look into the block diagram. In this diagram, there is n number of data inputs starts from D0, D1 up to Dn. So D0 is the LSB bit and Dn is the MSB bit, and M selection inputs, that is S0 to Sm, whereas S0 is the LSB bit and Sm is the MSB bit, but only one output is at the output side. Hence, out of n number of inputs, only one output is delivered at the output. Hence, the mux is also called as a data selector. Next, you will have a question. How to design a mux and how to calculate the selection lines for the mux. So, we have a formula to calculate the selection input, that is 2 power m is equal to n, whereas m is number of selection lines, n is number of data lines. Let's see with the example. Consider number of data lines, that is n is equal to 16. That is the data are D0, D1, D2, D3 up to D15. So we have 16 data inputs. So how many lines we require when we are designing the mux means apply the n value in the formula. 2 power m is equal to n, which implies m is equal to log 2 of n. So log 2 of 16 is 4. So m is equal to 4. So we need 4 selection lines for 16 input data lines. So the diagram becomes D0, D1 up to D15. These are the data inputs. The selection lines are S0, S1, S2, S3. So S0 is the LSB bit and S3 is the MSB bit. So these 4 selection lines are used to select the data inputs out of 16 data inputs. So the only one output is delivered at the time. Next, we will look into the types of multiplexer. So, the types of multiplexer are 2 cross 1 mux, 4 cross 1 mux, 8 cross 1 mux, 16 cross 1 mux. So, the inputs are increased. In first one, 2 inputs are there. In second one, 4 inputs are there. In third one, 8 inputs are there. In fourth one, 16 inputs are there. But in all the types, the output is single output. So for that, in first mux, 2 cross 1 mux, we need 1 selection lines. For 4 cross 1 mux, we need selection lines 2. In 8 cross 1 mux, we need selection line m is equal to 3. And for 16 cross 1 mux, we need m is equal to 4 selection lines. And I give some IC numbers for the multiplexers. Then we will see the applications. The multiplexers are mainly used in radio to select one channel from the many channels, and in computer to route the data, and in function generations, and in data acquisition systems. So these are all the best examples for the applications of multiplexer. Okay, in next class we will see how to implement the Boolean expressions using mux. Okay, thank you.